Hello everyone, this is CE241 Material Science class, and today we will be looking at the mechanical properties of materials in the chapter 2 of your textbook. For the first 4 weeks you have seen the nature and structure of materials, and in this video I will be giving a brief introduction on the mechanical properties of materials. But before I go further, let me turn my video off and turn my pointer on so that we can continue in a much better way. Well, mechanical properties are the properties that determine the response of engineering materials when they are subjected to some forces. I will try to explain this concept on a figure that you face every day. Well, I'm joking, of course you don't face this problem every day, but let's say that you are trying to cross this cliff. Which material would you pick to cross this cliff? Would you rather pick wood or would you rather pick steel? Well, this is an engineering problem about material selection, and you have seen clues about material selection in the first week of this course. And besides the material properties, you have seen that there may be other criteria like the cost, like availability, etc. But whatever material you pick, you should be facing a problem of, like, while you are crossing this bridge, because of this load, there will be some deformations, and you should be able to calculate these deformations by the time you graduate. So in this course, we are not trying to teach you how to calculate those deformations, but I'm trying to just explain the basic concept behind it. Now, how much deformation will take place when a certain amount of load is applied for that problem? That will depend on the mechanical properties of the material that you pick. But not only on that, that will also depend on the cross-sectional properties of the load-carrying member that you select. Like, you can pick huge, big logs like this, so you can carry this heavy machinery, or you can pick a tiny little rope that can just carry this man over here. So some materials deform more than the others when subjected to the same loads. I will try to explain you again by a schematic drawing that I prepared. Like, if you were to pull this rod longitudinally, you will observe some elongation. Even though you don't see in this video, there will be some shortening in the radial direction as well whenever you subject a material. And if you were to look at that load deformation plot or load elongation, some materials will behave like linearly as shown over here. Let's pick a steel rod. So if you are pulling steel rod uniaxially, longitudinally, the deformations will be linear, at least for a while. You will see later on that it's more complicated than that. But if you were to pick an aluminum rod of the same cross-section, and if you were to again conduct the same testing, you apply the load and look at the elongation, as you can see over here, they do not coincide. And for a certain load, let's say, for a certain load, the deformation that you observe in steel will be different than the deformation that you observe in aluminum. And this difference is because of the mechanical properties of the materials. In other words, even though both rods have the same cross-sectional properties, and they are, when subjected to the same loads, the response of steel is different than the response of aluminum. And that's obviously because the mechanical properties of steel and aluminum are different. And some materials break easily when compared to the others that can show large deformations before failure. Like on the left you see steel and on the right you see concrete. The steel, whenever you pull it uniaxially in a tensile force, the steel will deform, and we call this steel therefore a ductile material. Whereas if you were to subject concrete uniaxially, not in tension but in compression, let's say, you will not be able to see any deformation, at least by your eye, and the material or the concrete will break suddenly in a brittle way. This video again in a slower way, as you can see, no deformation, boom, it breaks easily, not easily, in a high load without any deformations. So, the response of materials to applied forces will depend on the type of bonding, the structural arrangement of atoms or molecules, and the type and number of imperfections which are always present in solids. Therefore, the mechanical properties are very sensitive to manufacturing processes and operations, because manufacturing processes and operations will always introduce some imperfections in the material. And you have seen these bonding, arrangement of atoms, the imperfections, and etc. But they are not the only cause, because the type of loading, like if you are compressing it or pushing it or pulling it in tension, or the mode of load application, you are statically applying the load, whereas like in an earthquake you are dynamically applying the load. These will change the behavior of a material to a greater degree sometimes than the chemical composition, than the heat treatment or temperature, which are parameters of the manufacturing process. And throughout the rest of the course, you will be hearing terms like elastic materials, elastoplastic materials, viscoelastic materials, modulus of elasticity, Poisson's ratio, isotropic, anisotropic materials, ductile versus brittle materials, delayed elasticity, and etc. But before we go further, we have to introduce some basic concepts, like what's a force, like what's a stress, like what's a deformation, like what's a strain. And in the next video, you will be seeing these, but when you graduate at the end of your civil engineering curriculum, you will be able to calculate, or you will be able to see the relations between those. Like in this course, you will be seeing whenever you apply a force, some stresses will be generated. Then there are some relations between stresses and strains. Basically, this is the mechanical properties. And from strains, you will be able to calculate the deformations. So when we are back to our first initial problems, whenever you apply a force, deformation will take place, and we can calculate those deformations using this loop. So this ends the first video. In our next video, we will be talking about the force and stress.